Okay, go and have a look at level 2 now. This is tricky, to be fair. The first one. So x over 1 add x. I don't have the derivative on top. It's not a bracket, so it's try your integration by parts here. So u is the easier one. dv by dx is the awkward one, which in this case is the bottom line. Now, differentiate this on this one. We're going to try to integrate a bracket. So remember how to integrate a bracket. Derivative must be in front, which I have. So you add 1 to the power, divide by it, and that comes up to be 2. So it's 2 and then your bracket. So you've got all your wee bits and pieces, uv, putting it in. Now, when you put it in and tidy it up, the first one becomes 2x, the square root of that, minus, bring that 2 outside so you can see your bracket nice and clearly there. You've got the derivative in front, just add 1 to the power and divide by it. Then you've got your limits to put in, so hopefully you can work through that. Part 2 is wanting you to do it by substitution. So what joy, we've got to do this question all over again using a different method. So x over 1 add x dx, and it's telling you to use this substitution. So du by dx, differentiate it, because you want to rearrange it to get your dx. So your dx becomes du. Your x, if you rewrite that, is u minus 1. The bottom line, that's your u bit to the power of a half. So split it up so it's u over u to the half minus 1 over u to the half. That cancels down to 1 take away a half because you subtract the powers, and that's bring it up. Now I've got limits in this one. So remember your limits are from 0 to 3. So whenever you're in terms of u, you've got to write them in terms of u's. So when x is 0, u is 1. So u is 1. That's my lower limit. And when x is 3 for my upper limit, u is 4. So now you have got it in a situation where you can integrate. So you just, that's gone blurry. Okay, so you add 1 to the power and divide by it, and just sub in your 4, sub in your 1, and away you go. In an exam, if it doesn't tell you which one to use whatever you prefer. I always prefer integration by parts because I hate the substitution, but I say in an exam, it'll be your own choice. Number 2, what have we got going on here? So number 2(1), x3 log 2x. Do you remember what I said? U is the easier one unless it's a log. So in this case, u is your log. So differentiate that. So it's derivative over the function, that cancels. Integrate that, I can integrate that straight off. I don't have to write anything fancy down, you can see it quite easy. Plug it into your wee formula. And you will notice then that this one here is easy enough to integrate. Let me just put it up. So you can just run through the rest of that. See the second example? This is in red for a reason. One of the most important things you will be going over. So can you please make sure you pay a special attention to this one. Right. That doesn't look like the product, but you cannot integrate a log. It's absolutely impossible. So what you do is we do a wee trick. We put a 1 in front of it to make it into a product. U is the easier one unless it's a log. So in this case, u is your log. dv by dx is the other one. You can differentiate a log, no problem. You can integrate that, no problem. Using your left-hand side of the formula. So it's u, v, minus v, du by dx. So that becomes x log x minus integral of 1. To integrate a 1, the x just reappears. Very, very important. So can you make sure you know that? Then we've got limits just to sub in here, so you just sub them in. Okay, what have we got in number 3? integral of tan. So I would write that as, because if you, sorry, before I go any further, remember your wee trig rules. Sine goes to cos, cos goes to minus sine, tan goes to sec squared, cosec goes to minus cosec cot, cot goes to minus cosec squared, and what was missing, sec goes to sec tan. You don't have anywhere that has got, where am I at, tan. None of those have got tan, so you can't go backwards. Okay, so how do you do that? Write tan as sine over cos. I've got a fraction. Do I have the derivative on top? The derivative of cos is a minus sine. So if you pop a wee minus up there and balance outside, you've got the derivative of the bottom on the top. So to integrate a fraction, you just log the bottom line plus c. Okay, it's quite a good wee question there to learn. Then you've got to do x sec squared dx. Okay, so it's a product. So let u be the easier one, dv by dx to be the harder one. Differentiate u, you get 1. Integrate this. Sec squared comes from tan. So just writing out the left hand or the right hand side of your formula. So it's u v minus v du by dx is just 1. You've just found this out in the previous part of the question. That's what you were doing. When it uses the word, told you to use your previous answer. If you ever see the word hence in exam, that means you use your previous answer. And I have just realised a minus sign in there, and that tidies it all up. So x tan x plus log modulus of cos x plus c. So that was quite an interesting wee question. I enjoyed that wee one. Question 4 I don't think is as bad. Use the easier one. dv by dx is the harder one. Differentiate u. Integrate this without writing it, as you know, is the integral sign. Derivative of that's a minus. So pop a minus in front and balance it outside. Then integrate it back. Plug it into your formula. And I think the rest of that should be okay. I'll just maybe talk you through what's happening here. Do you see the way I have got the derivative of this is a minus in front? So I just integrate that back. I don't have to do anything balancing there. So that's what's happened. It's not an error or anything, that is actually right. Okay, what's going on question 5? Right. Okay, I think I can talk this through rather than writing it out. Use the easier one. dv by dx is that one. Differentiate. Integrate. Where did sine come from? A cos goes to a minus sign. So you need a minus first of all. Derivative is a 2. Balance outside. So once you get that bit sussed, minus a half, sine goes back to cos 2x. Just plugging it into your formula. Blurry. Plugging it into your formula and then sticking your limits in at the end. Question 6. Does start to get repetitive. U is the easier one. du by dx. dv by dx is the harder one. Write the integral sign. Need a derivative, need a 3, balance outside. When you integrate it back, derivative disappears. Plug it all into your formula. And you see here, well, just want to talk to you about. Throw that third outside. Need a derivative in front, need a 3 in front. Balance outside with a third. And I should have a plus c on that. Okay, number 2. Oh, it's a clever wee one. It looks at the product rule. You can see I started off doing it by the product rule. And then I noticed the derivative of this is 3x squared. I can just pop a 3 there and a third outside. And I've got the derivative in front. Just go straight back to the e function. Very easy to miss that, as you can see. I missed it when I did it for the first time. And what have we got going on in this last one? Not as simple. Okay, I'll do this one out for you. Quite enjoy these longer ones. Okay, I don't have the derivative in front, so nothing easy to do there. U is the easier one. Just go through your normal business. dv by dx is the harder one. So it's I like to see the integral sign. I need the derivative in front, balance outside. When you integrate it back, derivative disappears. So uv minus v du by dx dx. So u v, I'm just going to put the third in front there to keep it a bit neater, minus v, I'm going to throw that third outside. Du by dx is 2x. I can see what's happening here. Third x squared e to the 3x. Bring that 2 outside. You can never bring a letter outside. It's only numbers can go through the integral sign. Can you see us going again with the product rule? So u, or the integration by parts, dv by dx is e to the 3x. Differentiate that. 1. Integrate this. Need the derivative in front. Balance outside. The balancing stays, the derivative disappears. So let's just do a wee wiggle down here. uv minus v du by dx dx. You can see why I just did with the right hand side, because it can get an absolute mess if you have too many equal signs as you go through it. e3x du by dx is a 1. So we've got a third x e to the 3x. Bring that third out there to give them a wee bit of a chance. Before I integrate that, I must have the derivative in front. Pop your 3 in, balance outside. So it's a third x e 3x minus a ninth. That integrates and derivative disappears. Right. See now where I'm at? So equals a third x squared e to the 3x minus 2/3 times this rigmarole. So lots of places you can make mistakes in here, and hopefully I haven't made one, but I will see in a second when I check with my original answers. E to the 3x minus 2/9 x e to the 3x plus 2 over 27 e to the 3x. So let's see if that matches up before I stop, and just plus C, and it's looking good.